Hello everyone, this is the first video of that polynomial series. So, introduction to polynomials and adding and subtracting polynomials. Enjoy. A polynomial is another type of function. A polynomial looks like this. It's like an expression, say y equals 3x to the 5 plus 2x cubed minus 3x squared plus 10x minus 50, something like that. This is a real big polynomial, okay? But what a polynomial is, it's like you've got x to the power of something, x to the power of something, x to the power of something. You've got a whole bunch of different exponents with x in them multiplied to a number, and you've got a whole bunch of terms added together. All right, so this here is what we call a polynomial. That's a real big one. We're not going to do any ones that big. Right, what we are going to do are three basic types. We've got three called, we've got monomials, binomials, and trinomials. I might start with trinomials first because it makes a bit more sense. A trinomial looks like this, like 10x to the power of 4 minus 5x plus 2. So here we actually have three terms here. Okay, that's why it's called a trinomial. 1, 2, 3. This is called leading coefficient here. This is called the degree here, okay? I might get to that a bit later though. But here we've got three terms added together. There's no x here, but actually there is an x. It's x to the power of 0. But when we've got x to the power of 0, we don't generally write that. We just leave it blank, okay? So that's called a trinomial. Another trinomial, for example, might be minus 5y plus y cubed plus 10y squared. It doesn't always have to be x, it can be any variable you like. Or another one might be 5 plus z squared minus 100 z to the power of 14. Okay, if you've got three terms, you have a trinomial. Binomials is two terms, so like 5a squared plus 3a. Or 7x to the power of 5 minus 11. Okay, you've got two terms. And a monomial is just one term. For example, 10x to the power of 43. Or 5. That number 5 is actually a polynomial. It's kind of like 5x to the power of 0. Right? But that does actually count as a polynomial. We would say it's like a constant value. And minus 3b to the power of 6. Okay, that could be a monomial as well. Alright, so that's what a polynomial is. You've only got positive exponents, okay? Or you could have zero exponents. Remember, this is like 2x to the power of 0. So polynomials can only have positive exponents and no fractions in the exponents either. Alright, so that is what a monomial, that is what monomials, binomials, and trinomials are. And when we say polynomials, poly means many, right? Poly means many. So let's try example 1. What we have here is a polynomial. 5q cubed minus 3q to the power of 4 plus q. That is a polynomial. What we're going to do is write this with decreasing exponents. So you see the largest exponent, the term with the largest exponents in the middle? We actually like to write it with the largest exponents on the left, and then we have the exponents going down. Let's do that. So rewriting that, it's just going to be, we put this one first, minus 3q to the 4. And what's the next highest exponent? Cubed. It's going to be plus 5q cubed. And then we've got, this is a q to the power of 1, isn't it? So that goes last, plus q. So this is like a standard form for how we write polynomials, with the powers, with the exponents going down. Okay? Then it says, state the polynomials, oh, bad grammar. State the polynomial's degree. What is the degree? The degree is the highest exponent that you can see. So here we've got an exponent, 1, 3, 4. The degree is 4, okay? It's the largest exponent in the polynomial. And when we write it like this, it's always at the front. And what's the leading coefficient? We're going to abbreviate that LC. The leading coefficient is, so what we have here, once we write it like this whole thing here, these are called terms, by the way. We've got three terms. This is called the leading term. And this tells you everything. Once you've got the leading term established, this tells you the degree. Okay, it's going to be that exponent there. The leading coefficient is the number at the front stuck, okay, to that variable with its exponent. All right, so the leading coefficient here is -3. Okay, so write it in standard form. Largest exponents on the left, smallest on the right. That's going to be your degree, and that's going to be your leading coefficient. Too easy. Next is example 2. What we're going to do now is look at these things here, these functions. We're going to ask, are these polynomials or not? And explain why if they are or not. By the way, go ahead, pause me anytime and work ahead, all right? It's best if you can try and get to the answer before I do. If yes, what is its degree and classify it? So the first one here, 5x cubed. Remember, a polynomial has to have non-negative integer exponents. In other words, the integers can be 0 or larger, and they must be whole numbers, no fractions in the exponents. So what about this first one here? X cubed, that's okay, times 5. Yes, this is all right. This is a polynomial. Classify it. What is its degree? Sorry, degree is, what's the highest exponent you can see? Well, there's only one exponent, 3, so this is degree 3. The leading coefficient would be 5, but we're not asked for that. State its degree and classify it. Classify it. Is it a monomial, binomial, or a trinomial? We only have one term, so this is a monomial. Okay, pause me. Go ahead and try and answer these first before I do, and then check it as I go through it. B, this one. Is this a polynomial or not? We have a negative exponent, so that's a no. It's not a polynomial. That one's done. C, this one here. State is this a polynomial or not? Yes, it is. Okay, this is, we've got only positive exponents here. That's a 1. That's okay. So that's a yes. What's its degree? The degree is, what's the largest exponent you can see? All this is already written in our standard form with the exponents going down. So the degree is 4. The leading coefficient is 1 if you're asked, but we're not asked here. Okay, and the last thing, classify it. We've got 1, 2, 3 terms, so this is a trinomial. And the last one, D, is that a polynomial or not? Well, we've got a positive exponent here, but no, it's not written in the standard form yet. In standard form, we always write it like this, 9. This is going to be 9 times 1 over m, right, which is 9. What's another way you can write that without a fraction? That would be 9m to the minus 1. Remember your exponent rules? So this actually has a negative exponent, which means it's not a polynomial. That's a no, okay? Example 3, the last example. What we're going to do is find the sum or the difference of two polynomials. So here we're going to add two polynomials. We've got one polynomial plus another polynomial. And we're going to get the answer to this. So this is just collecting like terms, believe it or not. So since it's a plus, these brackets don't really mean anything. So let's just write this again without the brackets. 2x squared plus 3x minus x cubed plus 3x squared plus x cubed minus 12. Now all we're doing is just collecting like terms. So let's write the final answer in our sort of standard form for a polynomial. Let's write the largest exponents first. We've got minus 1x cubed plus 1x cubed. So they actually just die out. Okay, it's going to be 0x cubed. What's left? We've got negative 2x squared plus 3x squared. So we're going to get a 1x squared here, which is just x squared. What else? 3x. Are there any other x terms? No, so that just copies down. Plus 3x. Anything else? Negative 12. Negative 12. Just copies down as well. So this is actually our answer right here. We can't go any further. Right? These are unlike terms, so there's nothing we can do there. We actually just stop right there. That's the answer, okay? So this has a degree 2, leading coefficient of 1. Right? And we have a trinomial as our answer. B, the second one, let's try this one. Okay, so this time we have a subtraction here. So how can we rewrite this with no brackets? Well, what we do is we treat this like a minus 1 at the front, and we do like a distributive property. Okay, remember the distributive property. So writing this without brackets, 5y squared plus 2y minus 4. Minus 1 times minus y squared is plus y squared. Minus 1 times plus 4y is minus 4y. minus 1 times minus 3 is plus 3. Let me just check that. Are we right? Minus, minus, plus, minus, plus, minus, 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 plus. Now all we do, it's just the same as this going from here to here. We just collect the like terms. And you know what? I'm not going to do it. I want you to do it and then write what you think the answer is in the comments. Okay, so the answer is going to look like this. What are the missing numbers there? Just write out the whole polynomial in the comments. By the way, how do you write an exponent? How do you type an exponent? So if I was going to write 5x cubed, if I type that in, okay, it would be 5, and we use a star for multiplication, x, and we use this thing called a caret symbol. Okay, so that's how we write type 5x cubed. We probably don't really need this actually, right? Just like that's fine. Okay, so what would be the final polynomial here? Type it into the comments and have a bit of a discussion about it. See if anybody disagrees. You can have a bit of an argument. Be nice though, okay? Don't get cranky.